In this video, we're talking about how to find the measurements of different types of quadrilaterals. And when we say quadrilaterals, we mean polygons that have 4 sides. And there are 2 general families of quadrilaterals, trapezoids being one family, which is a quadrilateral that has just one pair of parallel sides, parallelograms being the other family of quadrilaterals, where parallelograms have 2 pairs of parallel sides. So we're going to be focusing on parallelograms in this particular video, and we're going to be looking for the measurements of sides, diagonals, and angles of parallelograms. So we're going to start with this simple parallelogram here. Later on, we're going to talk about 2 special cases of parallelograms called a rhombus and a rectangle. But for now, we're going to start with this parallelogram. So again, a parallelogram is a 4-sided figure called a quadrilateral that has 2 pairs of parallel sides. So since we know it has 2 pairs of parallel sides, what we can do is go ahead and indicate that opposite sides are parallel, which we do using these little arrows here. So we indicate that these 2 sides are parallel and that these 2 sides are parallel to one another. Now we also know in parallelograms that opposite sides are congruent, so the measure of this side will be equal to the measure of this side, and the measure of this side will be equal to the measure of this side. Now within parallelograms we can also say that opposite angles are congruent, so this angle here has to be equal to this angle here, and this angle will be equal to this angle. And we know in parallelograms that the diagonals of the parallelogram bisect each other, which means that the distance from A to V is going to be equal to the distance from V to C, and the distance from B to V is going to be equal to the distance from D to V. Now there are even more things we can say about parallelograms, but these are the basics, and we've been given some information about this parallelogram, and then we've been asked to find some extra information. So let's go ahead and add the given information to our diagram here. Now we've been told that the line segment AB is equal to 10. We find the line segment AB here, and this is equal to 10. So knowing that that's equal to 10, we know that opposite sides are congruent in a parallelogram, so we can go ahead and also indicate that this side is equal to 10. We know that side AD is equal to 4. Here's AD. This is equal to 4. So knowing that opposite sides are congruent, we can say that this side is also equal to 4. We know that AC is equal to 13. So AC here is the diagonal. That's going to be equal to 13. So we'll just indicate here 13. And we know that the measure of angle ABC is 130 degrees. So ABC is 130, so this right here is going to be 130 degrees. We know that opposite angles are congruent, so we can say that this angle is also equal to 130 degrees. So we've just added the information we've been given. Now let's go ahead and find the values we've been asked for. So we've been asked to find the measure of side CD. CD is this side here, the bottom side. Well, we already know that's 10. We already marked it because we know that the opposite side is 10, and we know that opposite sides in a parallelogram are congruent. So we can say that this is also equal to 10. Side BC is this side right here, and we already indicated that that was equal to 4 because we were given the measure of the opposite side, AD, and we know that opposite sides are congruent. We're looking for now the measure of AV. Well, that's this line segment here from A to V. We know that AC, this entire diagonal, is 13. And remember we said that the distance from A to V and the distance from V to C were going to be congruent. Since we know the whole distance is 13, we know that AV has to be exactly half of 13, which is going to be 6.5. So we can say AV is equal to 6.5. And then we're looking for VC, which is the other half of that diagonal 13, and we know that's also equal to 6.5 because AV and VC are congruent. They're going to be equal. What about the measure of angle ADC? ADC, that's going to be this angle right here. We already know that's 130 degrees because we were given the measure of the opposite angle, and we know that opposite angles are congruent. So this is going to be 130 degrees. And then we're looking for the measure of angle BAD. So BAD, that's going to be this angle up in this corner right here. Well, in the same way that the sum of the interior angles of a triangle is 180 degrees, the sum of the interior angles of a parallelogram will always be 360 degrees. So the 4 interior angles, this one, this one, this one, and this one, these 4 interior angles are going to add up to 180 degrees. We already know that these 2 angles are 130, so they take up together 260 degrees of the 180. Since these two angles here, these other unknown angles, are congruent, that means they have to be equal to each other. So if we've already taken up 260 degrees, and we know that the sum of all of these is 360 degrees, we know that this angle plus this angle is going to have to be 100 degrees, and since they're equal to each other, that means they both must be 50 degrees. So we can say that BAD is going to be equal to 50 degrees, and we can indicate that up here, 50 degrees. That must mean that BCD is also 50 degrees, and so then we can say BCD, that's 50 degrees, and we found all the measurements of interior angles. This brings up another interesting point about parallelograms, which is that consecutive angles, angles that are next to each other, are going to add to 180 degrees. So B and C are next to each other, 130 plus 50 is 180. D and C are next to each other, 130 plus 150 is 180. A and D are next to each other, 50 plus 130 is 180, and A and B are next to each other, 50 plus 130 is 180. So consecutive angles are always going to add to 100 degrees, and that should make sense because if two consecutive angles add to 180 and two other consecutive angles add to 180, then the sum of all of the angles in the parallelogram is going to be 360 degrees like we said before. Now, let's talk about the special instance of a parallelogram called a rhombus. A rhombus is a special parallelogram where all four sides of the parallelogram are congruent, meaning that the lengths of all four of the sides are equal to one another. A square is an example of a rhombus. So we know the same things about a rhombus that we know about a parallelogram, namely that opposite sides are parallel, so we can say opposite sides are parallel like this. We know that all sides are congruent, like we just said, so all sides are going to have an equal measure. Just like in a parallelogram, opposite angles are going to be congruent, so this angle will be equal to this angle, and this angle will be equal to this angle. And again, the diagonals bisect each other, which means that this measure is going to be equal to this measure, and this measure will be equal to this measure. The other thing that makes a rhombus special is that the diagonals are perpendicular to one another, so all four of these angles here are going to be 90 degrees, and we can go ahead and indicate that. Now let's add the information we've been given. We've been told that the line segment EF is 21, so we'll go ahead and indicate 21 here. Of course, because it's a rhombus and all four sides are congruent, we can also say from that information that these other three sides are 21. We've been told that EG is 15, so EG is 15. This diagonal here, this vertical diagonal, is 15, so we'll go ahead and indicate 15. And we've been told that the measure of angle EFG, so EFG, so right over here at F, is 70 degrees. So this is going to be 70 degrees. Opposite angles are congruent in a rhombus, just like they are in a parallelogram, so we're also going to have 70 degrees over here. Now let's look at what we've been asked to find. We've been asked to find the measure of side FG. Well, we already know that that's 21 because we were told that EF was 21, and we know that the lengths of all four sides of a rhombus are the same. Same thing here with GH, that's going to be 21, that side. And now we're looking for EV, so EV. Well, we know that the length of this vertical diagonal is 15, and we know that EV and VG are the same distance, so we just have to take half of 15, which is 7.5, and say that EV is 7.5. Similarly here, we also know that VG will be 7.5, again because EV and VG are congruent because the diagonals bisect each other. Now what about the measure of angle EHG? EHG, that's going to be over here by H. Well, we already know that's 70 degrees because we were given EFG as 70 degrees, and we know that opposite angles are congruent. So this is going to be 70 degrees. FEH, so FEH, so that's this angle up here at E. Well, again, just like a parallelogram, in any quadrilateral, we know that the four interior angles of the quadrilateral add to 360 degrees. We already have 70 and 70, so that's 140. If we take 360 minus 140, we get 220. So we have 220 degrees to divide between this angle up here and this angle down here. Well, because these are opposite angles, we know that they're congruent and they have to be the same, which means that we take 220, we divide it by 2, and we get 110. So that means that FEH is going to be 110 degrees. And its opposite angle, if we were asked for it, FGH, will also be 110 degrees. What about the measure of angle EVF? Well, that's EVF right here. That's where the diagonals intersect one another. Well, we already know that that's 90 degrees. All four of these angles are 90 degrees. By the definition of a rhombus, when all four sides are equal to one another, the diagonals are going to be perpendicular to one another. So this is going to be equal to 90 degrees. And the measure of angle GVH, so GVH, again, that's another one of the four angles where the diagonals intersect one another. That's also going to be 90 degrees. So we can go ahead and indicate that angle. Now, if we look at a rectangle here, a rectangle is a special case of a parallelogram where all four of the interior angles are right angles. So all four of these are right angles. But similarly to a parallelogram, we can still say that opposite sides are parallel. So we can indicate opposite sides parallel like this. We can also say, like a parallelogram, that opposite sides are congruent. So these two will be the same, these two will be the same. We also know with a rectangle that its diagonals are congruent, meaning that they're equal and that they bisect each other, which means that this length I to V is going to be the same as L to V, which is going to be the same as K to V, which is going to be the same as J to V. So all of these are equal to one another. Let's look at the information that we've been given here. We know that IL is equal to 6, so let's go ahead and indicate that IL is 6. Because we know that opposite sides are congruent, we can also say that this side is 6. IJ is 8, so IJ up here is 8. Because opposite sides are congruent, we can say this is 8 also. We know IK is 10, so I to K, this whole diagonal here is 10, so I can indicate 10. Now we need to find JK. So JK here we already know is 6 because we were told IL is 6, so this is going to be equal to 6. KL here, this side, we already know is 8 because we were told that IJ was 8, so this will be 8. JL, so JL, this diagonal here, well, we know that the diagonals of a rectangle are congruent, and we know that the other diagonal is 10, so this diagonal also has to be 10. We need to find IV. Well, IV, that's just going to be half of the diagonal, which we know is 10, so this is going to be 5, half of 10. And then LV, LV, so the opposite diagonal, but again, all four of these pieces are congruent because we know this whole diagonal is 10, we know that this half is 5 and that this half is 5, and because these are all equal, we know that this is 5 and this is 5. So again, LV, L to V, is also going to be equal to 5. And those are just some of the ways that we can use what we know about parallelograms to find the measurements of sides, diagonals, and angles.